Okay. So our learning target today, guys, is that you can use the law of cosines that we derived the other day and we practiced on Tuesday to kind of solve a variety of problems. And the way we're going to do that is first I'm going to show you how to do it with a missing angle. So that was like the challenge problem last night. And now I'm going to show you exactly what that looks like. And then we're going to look at, can you determine whether you're looking for a side or an angle? Which most times is as easy as looking at the question. If the question says find an angle, you're going to find an angle. If it says find a side, you're going to find a side. Sometimes in the word problems, it won't use the word side or angle. There'll be some other synonyms for that, like how far between two boats. If I'm talking about how far, I'm talking about what?
Side.
A side. And so you might see stuff like that later on. And then after that, what we're going to do is you see 6 problems up around the room. You're going to practice drawing a picture, okay, giving me the work, and then answering in a complete sentence so that I know that your interpretation is correct. So not only that you have like 5.7, but that you know it's 5.7 millimeters or something of that nature. All right. So, law of cosines, when we're trying to find, if we see a problem like this, so take a second and write this problem down. So what we have is find angle A, which tells us we're looking for an angle. If A equals 14, B equals 16, and C equals 20. It says round to the nearest whole degree. Remembering that if I didn't put units here, our default thinking, or sorry, if I didn't put the decimals that I wanted, our default thinking with degrees is always whole degree, right? Our default thinking with side length is always how many decimals? 3. Good. And then we have to pay attention to the directions to make an adjustment if we need to. Alright, so my first step, guys, tends to be just to write the law of cosines. So I have a squared equals b squared plus c squared minus 2bc cosine a. How many different equations did I have you write down for the law of cosines?
3.
3. But what did we know about all 3?
They're the same.
What's that?
They were the same.
That they're actually the same because it really doesn't matter what's A and what's B and what's C. In fact, when we're given JKL, there's no A, B, C. What matters is that lowercase a, which always represents the side, will always be opposite the angle. So if I say that you want, if you're missing capital A, which is the angle, you're going to use the one that has capital A at the end and lowercase a at the other side. You always want your unknown to be either this one or this one. One of those two. When we were looking for a side, we always made it this one. When you're looking for an angle, you're always going to make it that one. My next step is to use my substitution property, which says if A equals 14, then it's going to equal 14 all the way through. So I look and I have my 14 on this side. Notice when we're looking for an angle that the one we don't fill in is after the cosine. Because with all trig functions, what type of measurement always comes after sine, cosine, tangent? What type of measurement?
An angle.
An angle. Good. Guesses as to what I'm going to do now. A lot of you, some of you got this right on your homework, so some of you know.
Multiply.
A little louder?
Enter it so like you have it, you do 14 squared equals, you got 16 squared and 20 squared and then minus the number cosine A.
Okay, so all those little processes that you just talked about, that's called simplifying. So you're giving me the specific ones. Here, I took my 3 numbers and squared them. And then I took these 3 and I multiplied them. Next step, I combine 256 and 400. I do not combine, this is where the first mistake I see comes in. People say 656 minus 640 is 16. But very few of you would know, or would do this incorrectly. If I gave you something like 10 equals 5 minus 2x, you don't take the 5 and minus 2. This doesn't equal 3x because these are not what?
Like terms.
Like terms. Good. These are unlike terms, so you can't combine them. So instead of combining these, what would I do to solve this? I would take my 5 and I'd minus 5 so that I got 5 equals negative 2x. And then I'd divide. We need to make sure we do the same thing here, because the cosine of A is a lot like our x. So this is something we know. Except now we have to think, okay, what's unknown is not x, what's unknown is the cosine of A. So our next step here is to subtract 656, right? And then that gives me my negative 640 over here, just like I have my negative 2 here. And my last step is going to be to do what? Or my next step, I should say. Divide by negative 640. And that's going to give you 460 over 640 equals cosine of A. Remembering that when I divide by a negative, if I have two negatives, they're going to cancel out and give me a positive. Could I reduce this? Absolutely. Would it change my answer? No. Do I have to reduce it? No. What I have to do now is recognize that this is the cosine of some angle equaling a ratio. When we have that, we have to take the inverse cosine, which looks like this. I take that, I put it into my calculator. Everybody try that just to make sure that you're still doing well with inputting information into your calculator. Okay? Always make sure you're in degree mode here. Once you do that, compare with your neighbor. Switch calculators with your neighbor for a second. Make sure you both have the same thing. Sarah, check with Isaiah maybe. Okay, raise your hand if you have the same thing as your neighbor. Did you check?
I didn't check it out.
You didn't check? Okay.
I don't have my calculator, so I just wrote.
Gotcha. That's why we come prepared to class, guys.
I know, right?
Alright, and our final answer based on this, remember we have to go back here, is what?
44
I
degrees.
plugged it in.
44 degrees. Okay? Questions on this process, guys? What's really important to recognize, and I'm just going to do one last little thing on this, is that you are still given how many pieces of information? And that you still need to find the fourth. And that our law of cosines has 4 variables in it. And granted, these are also variables, but they are just repeats of the b and the c. And the key is that we have 3 of 4 variables, but we don't have any what?
Opposites.
Louder?
Opposites.
Yeah, opposite pairs. Because if we had one opposite pair, does anyone remember what we're going to do?
Law of sines.
We're going to use the law of sines. Okay? And so we have to kind of think about that. When are we going to use the law of sines? When we have one pair and one other piece of information. When are we going to use the law of cosines? When we have 3 pieces of information but no pairs. The way you see that, remember, and now we're thinking back to geometry, we're going to use our law of cosines when we either have side, angle, side, or side, side, side. Okay? And this isn't about triangle congruency, although that's where you know those types of phrases from. This is about when you can use the law of cosines to solve for a missing piece. Alright, and so what we've done at this point, guys, is basically look at, I'm not going to click back through them actually, we've looked at the law of cosines, and we figured out how to find a missing angle. I'm going to give you 2 to try by yourself in your notes. Okay, so you're going to try these 2 problems. Problem 1.
What are we solving for?
I will tell you in a second. And you are going to find here angle B, and here you are going to find angle B also. And I want you to think about one of these, something is going to happen that looks a little different, and you have to explain to me why you get the answer you do, and what is different about it. Okay, so you're going to get to a point where you can't go any further with one of these problems. At that point, explain to me why you think you can't go further. Okay? Let me hit that stop.